My name is Shannon Moffett. I work for Cemex. This is Leo. He works for Prometheus. Welcome to our presentation on the path to net zero, the role of materials and collaboration. So, like I said, I'm Director of Market Development for Cemex. I've been with Cemex for the past 23 years. Most of my role has been on the technical side, so mix designs, ready mix, cement, aggregates, admixtures. Leo and I met through a mutual cement customer, and I learned about the products that they produce and decided it would be a good idea for us to try and partner on a job, and we're working through that now. So.
I'm Leo Atencio. I am the Director of Business Development for Prometheus. We are an algae-based blended SCM. I've been in the ready mix and concrete world for about 30 years now. Worked for a lot of the international cement producers prior to coming to Prometheus. And so today is really just showing how we combined as forces to try and solve a lot of the embodied carbon challenges that are affecting our world, and showing that collaboration is going to be the key going forward.
So our agenda, elements required to pursue a net zero carbon build, available low carbon cement materials, which is Prometheus, the key stakeholders, collaborative process, the drive innovation and make lower carbon net zero builds possible, and we'll explore how carbon budgeting supports early goal setting and material alignment, and then question and answer and discussion afterwards. And for us, it's more of a collaborative conversation. Feel free to ask any questions whenever you want to, and we'll do the best we can. Otherwise, we'll wait till the end and then do a panel question and answer. So what's really required, and based on our experience, we need collaboration prior to starting a project. For us, as a ready mix producer, as a cement producer, aggregate producer, typically the process is we get asked for a bid on ready mix level, and so we're competing against another ready mix producer on price, and it doesn't give us an advantage, or it doesn't give us an opportunity to showcase what we can actually do, the products that we're working on and the solutions that we can offer. So what starts the process is the owner, really at the owner level, and then that trickles down to the architect engineer, then the general contractor, and then for us, our customer is the place and finish contractor, who, is typically a lot more risk averse than maybe the owner, general contractor. And ultimately, it's up to us as a concrete supplier to figure out how to make something work. And how do we address risk with new technologies? I think we do as much testing as we can up front, and then we find partnerships and find minimal risk opportunities. So residential flat work, or building pads, equipment pads, something less structural, less significant to try a new material, and that's what we're trying to do. Leo has some stories and experiences, case studies where they're already actually using it in slabs and hard trowel slabs, and it's working fine. Our testing and experience so far is everything's been working well. Where do you really start? So utilize performance-based specifications. Most of the time, what we deal with is, as a ready mix producer, we'll get structural general notes or specifications, and most of the time those are very prescriptive. And so with a carbon reduction goal, as a minimum, you need to start with performance-based specifications. Don't limit water cement ratios. Don't limit SCM contents or types. Ultimately, as a ready mix producer, we're responsible for the performance of the concrete. If there's a, low break or something, then we'll investigate it the same way you do with conventional concrete. The building codes already require us to do over designs, already have exposure categories, and that essentially dictates what our mixes are going to be in the first place. So we don't necessarily need more prescriptive specifications. Other elements, structural design optimization. So MIT presented earlier today the Concrete Sustainability Hub. They have a structural engineer who's working on design optimization, various shapes to eliminate volume of material. And so based on what we've seen so far, you can eliminate 50% of your carbon, embodied carbon in the concrete, and ultimately that amounts to reduced volume and usage of concrete. That's a starting point. And then, the actual concrete mix design of materials is a secondary process. In the future, we feel like modular buildings, prefabricated units, much tighter tolerances, much better control, lower standard deviations, which mean lower over-design requirements for the concrete, another way to reduce embodied carbon. From a constructability standpoint, strength requirements, yes, we understand 28-day acceptance age for concrete typically, but as we move to the future with higher SCM contents, then we need to go to 56-day specs or even 90-day specs. Early age strength, 1 day, 3 day for, let's say, stripping forms, post-tension slabs. One approach is maturity method, and then we found that, in general, we could save about a sack total cementitious, hitting the same strength, but by using maturity method as opposed to just relying on cylinders. And then, obviously that depends on the application. For us, column shear walls, we can run 50, 70% SCM. Slab on grades, elevated slabs, the hard trout surfaces, that's going to be contractor dependent, and the contractors are really going to dictate what they feel comfortable with. We can produce the mixes, but ultimately we need a place and finish contractor who's willing to use those mixes.
No, oh geez, there it is. The place and finish crew, that sector is undervalued. They are the ones that really have to finish, regardless of the solution, satisfy the owners. And so one of the things that we really targeted was the place and finish contractors. Having them have an ability to place and finish something that they feel comfortable with. It doesn't create a lot of labor demand. It doesn't create a lot of equipment. That's one of the things with a lot of the novel products like us, is really looking at that sector. So although you have the 7, 14, 28-day breaks, really looking at how does that slab finish, because a lot of people will tell you, yeah, we can create a low embodied carbon design with all these new materials, but then when we go to place it, it doesn't work. And so then that sets the market back a little bit more because they said, well, we tried it. So that is a segment as you go into these. And when you talk about collaboration, don't undervalue that segment of the value chain because it is very important to the success of not only the product, but to what the owner is going to receive at the end.
Leo, I guess from your experience, what's been the process like, or the collaboration discussion? I guess the first round of roadblocks that you typically deal with when you want to introduce a new product?
So for us, the path was long, right? So some of that the engineers and architects have always been very receptive to trying new materials, but then you're dealing with, again, from our standpoint, and a lot of the other challenges were scalability. We love the fact that you have a product, but I'm going to build multi-family complex. I don't want to be just doing the foundations and then have to stop. So that was a piece of really looking at scalability, which we own, and we took that on. So that's where it really starts. Then it's getting with a general contractor that is willing to take the risk a little bit further and say, okay, I'll use you in a low-risk application, whether that is something in site work, utilities. And then once they got that achieved, then it was like, okay, now we're going to go forward. So in that regard to the construction building, it was taking risk, each person's risk, only so far, and then picking it up and moving the baton a little further. Then when it came to the actual deployment, the ready mix producers, it was giving them material, allowing them to take their mix design. That's the way we've worked, is said, let us use your bread and butter mix design. You take our material, replace up to whatever that value is. For us, we can go up to 40%, but every material is a little different, and see how it works. and then we'll work backwards from that. But really letting them have, like, you guys do what you do, get the results that you want, and then we'll work backwards. If they said, Leo, you know what, it didn't perform as well, okay, let us see the mix design. We would collaborate, we'd share materials, because we're not privy to local aggregates or local cement, but that's been it. But that delay or that time frame is always going to be 28 days because that's what everybody wants to see. But early on, if they're seeing positive results, they're like, okay, we'll go forward. And then we're very collaborative, very open, and that hasn't always been the case in the segment for a long, long time. So that's kind of what we've done.
So, I mean, I think a lot of us understand, levers as when it comes to cement and concrete to reduce embodied carbon, but we'll go through them. So, a starting point would be a 1L cement, it's Portland limestone cement. Contractor-wise, back 2021, the U.S. as a whole, I think the usage of 1L was about 6% across the U.S. Now that number is over 60%. Really, what is it? So essentially we're pulling clinker out of cement and then replacing it with limestone. The original ASTM C150 allowed up to 5% limestone in the first place. And so, yes, ASTM now allows up to 15% in a 1L cement, but in reality, most producers are only up to 12%. Why do contractors believe 1L cements are the root cause of their problems? Well, the first new material that goes in concrete and the first bad experience that somebody has, they're automatically going to blame it on whatever that material is. They'll tell you they've been doing it for 50 years and they know exactly how to finish concrete and it must be your product. Another typical options, conventional options. So, typical SEMs, ashes, Class C, Class F, slag, natural pozzolans out west. We believe we'll see a whole lot more natural pozzolan usage in the future. In your market, Denver, you use natural pozzolans. Up Northern California, Reno, we use natural pozzolans. I mean, basic stuff, concrete mix design, aggregate, optimized gradations. Obviously, we could reduce cement content through that as well. And then now we'll get into the available lower carbon materials.
So this is, we found this. This is a great slide. This just shows all of the available technologies that are out there. Again, and I'm sure not everybody's represented here. And it's exciting. It's an exciting space to be in. I look back, and Shannon and I were talking earlier, you would have never seen an SCM and a cement manufacturer in the same room, 10, 15 years ago. And now that that you have to have that collaboration is really driving progress. The other thing that's happening is that all of them are involved in some form of ASTM, whether it's a standard, they're involved in the committees. And so that's definitely helped us. And then the other thing that's also helped is being ASTM and ACI and the building codes being receptive to the materials. It used to take a long time to get through this, and when we first started, we were worried, like, we don't have that long of a runway. And now you're seeing progress accelerated through some of these standards. The other thing, too, is it's for us in this industry, and we're one of the small cubes on there, every success that any of us has just propels the next material forward, and that's what we're hoping to do is ride the coattails, pozzolan or fly ash that came before us, and then just take that and propel somebody else as well. So it's exciting technology. A lot of people are here representing their products, but it's going to take all of us to overcome a lot of these challenges. So I get like this one here again, this just looking at different technologies. You've got clinker reduction, which Shannon talked about, the LC3s, which are great, geopolymers, which at one point had a really bad name, but they've come a long way. Processes on how they're innovating it, being able to satisfy a lot of the ASTM standards. And then you've got ongoing pilot programs, and that's the big thing too, is just finding areas where people will say, let's use your material in 10 to 15 cubic yard increments, but over time that grows and it becomes all of a sudden you're in a convention center. So there's a lot of innovation coming.
So, I mean, for us, I think the various stages of innovation and implementation, We have the novel concrete. We have materials and mixtures that lack the appropriate testing in the lab, and then we'll move on to pilot-ready materials that we have testing in the lab completed, and then whether or not something is market-ready. So, Prometheus, one of my first questions for Leo was, okay, is your product market-ready? Have you sold it? Have you used it anywhere? And once we learn that information, then we start our testing, and then eventually we hope to get to the point to implement it on a project.
So this one here is big for us. This is kind of the value chain that of all the players that are involved in that decision making, and each one carries risk only so far. So as we were deploying, we had to understand, okay, what are you willing to do as the owner, and what changes are you trying to make? So if the owner had real aggressive low embodied carbon goals, we'd say, okay, we can meet that. And then as you started the conversations, they'd say, okay, we don't need to go all the way for the home run right now. We just want to get it in place. So then we would take the owner's information, we'd go to the architect and the structural engineer, and they would say, okay, what test data do you have? So we had a lot of third-party validation. We understood our material from the chemistry side as well as the physical and performance side. Sharing that information, which a long time ago we wouldn't have done as an industry, we would have held it tight to the vest, but trying to be transparent as much as possible and lowering those risk-averse conversations. Then now, which has been wonderful, you have sustainability consultants that are learning this material for their owners and their representatives and trying to educate that staff. Again, just letting them know where we're at. Again, and Shannon hits on it, the biggest thing for the new products is scalability. Can you produce? I have a project in California, but I have one in New York, and I have one in the Midwest. So that's a big one. But the sustainability consultants have really helped with validating either the LCAs or the EPDs that are required now. Then we get to the suppliers, and that is where a lot of it, I wouldn't say slows down, but that's really where you start to see how does it go through the plant? How disruptive are you to the production and manufacturing? Can we deliver this on this project? Because at the end of the day, that ready-mix producer really owns that relationship. And so what we're trying to do is say, we'll go into that conversation with you. And we've been called in with ready-mix producers and their customers to say, is this stuff really going to work? Do you have enough? What does it look like? And a lot of that validation from the ready-mix producers, really, once they're comfortable, it can move really quickly, which is what we're seeing with Cemex and them. And then at the end of the day, you've got the construction firms. So being able to tie help them out. We actually get requests from construction firms that will say, hey, we have an owner that wants to use your material, but they have these 6 or 7 questions, and where else has it been used? Nobody wants to go first, and that's a challenge, right? What I would tell you is there's enough applications, low-risk applications on a construction project to try these out. You can use it in flow fill. You can do a duct bank. You can do light pole bases. You can do equipment pads. But luckily for us, someone was willing to say, okay, we'll take it and go first. And that's really helped us. But that's the one piece that I would say there's enough underground utility work as well that some people can use it as carbon sink or something like that. But there's definitely opportunities, but no one wants to go first. And so luckily we've been able to do that. So.
Now we'll get into carbon budgeting. So, a framework for developing a realistic carbon budget. We all know that concrete is very regional, and so availability of regional materials, what we have available to work with in a given market, is really what the ready-mix producer is going to have to work with. And for us, we'll only end up at a realistic carbon budget knowing our materials. For example, Bay Area of California, we can do very low carbon concrete. Plant configuration, operationally, we need multiple silos. We need at least 3 silos to run ternary mixes. Obviously, we need the applications, and we need the raw materials. So we import slag into the Bay Area and the Southern California as well. We also have access to ash, and then there's lower carbon cements available as well, 1L cements. you know, you have to understand the project constraints. So schedule-wise, you know, what commitments does the general contractor have, and what commitments are they requiring of the place and finish contractor? And then collaboration between the ready mix producer, place and finish contractor is important, because we need to provide a mix that's not going to impact the schedule. Maturity method would help for elevated work. But again, you know, you pull clinker out of concrete, then you need to replace it with something. Obviously, we're gonna cause some sort of a set delay. It doesn't need to be significant. The strength delay doesn't need to be significant. I think, you know, the perception is that if we pull, you know, 50% of the cement out of a mix, then automatically we're gonna end up with, you know, half the strength in concrete, and that's not the case. You know, all of the natural pozzolans, ashes, slags, they don't really work until there's the cement hydration happens. The byproduct of cement hydration is calcium hydroxide, the free lime, and then all of the SCMs react with the free lime to produce more calcium silicate hydrate, which is where the concrete strength happens. So yes, we slow things down a little bit, but it's not to the extreme that I think contractors in general believe that it's going to be.
The only other thing that I would say is that when you get to the concrete performance, that is one thing that most of the people that were in that one slide really know their materials. And so our role, we own that piece of educating and understanding what that is. And I think that's one piece that we have really taken seriously as new products, is saying we have to understand how these are going to perform. Especially with, like, we're in Colorado, that's where we're based out of. So the freeze thaw, you've got snow, you've got wind. Every climate is unique, but we've found a way to make concrete work for hundreds of years. Now we're just introducing something different. But as one of the new products in the marketplace, we do take that responsibility and that accountability of being able to understand how this is going to perform. And again, it's low risk applications. If someone said, hey, we're willing to try something in Florida, let's do some stuff, which we've done, just to see how it sits and how it acts in that humidity and that environment, is very, very acceptable.
Yeah, we kind of went through a lot of this already, but how to specify, you know, low carbon concrete. I mean, again, construction schedules, ACI 318 standard code for structural concrete. The exposure categories are really what's going to dictate the concrete mix design. Going back to performance-based specifications, so allow blended cement, 595 cement, or purely performance-based 1157 cement. Yeah, don't use a go, no-go specification, meaning there's no need to require minimum cement contents or binder contents. There's no need to limit SCM contents. The contractor, the ready mix producer, we know our materials, so we're going to know what our customer needs, the place and finish contractor, and then we're obviously not going to provide them something that they can't work with. I mean, yeah, incentives can work at times. I guess for Leo, for your product, I mean, you rely on some of the hyperscaler, you know, separate funds for special materials, pilot programs, right?
Yeah, so we are doing that. The other thing that's not on here is the legislation that's in place, right? So you have a lot of municipalities that have targets for, you know, materials that have low embodied carbon. Some of them right now, based off of where we started, have really come a long way. There's a few that aren't aggressive enough to where you'd say, okay, this really makes sense, and this is where one of these products would come in. I think there's a conservative piece that's happening with that and trying to step down those embodied carbon goals. But as these materials start to perform, hopefully they can say, okay, you know what, instead of waiting until 2026 or 2030 to have these, now that we're seeing performance, we may be able to help propel those a little quicker. But that's a big piece too, is the incentives at the legislation level. In Colorado and city and county of Denver, they just started, I think it was the beginning November 1st, they have a program that is looking for projects, and if there is a cost difference between what was normal and what would help them achieve what they have a Buy Clean Colorado Act, they're helping to offset that premium to start to motivate people to do that. So those types of things are things that can also help as looking at that legislation in your local state and communities.
Early communication obviously is essential. Part of what I've been doing just because of the technical background, so companies will ask for help in a carbon budget, and then I'll log into Climate Earth as our administrator for our EPD program. 280 plus ready mix plants across the U.S. We can produce EPDs on demand, any of our mixes out of any of our plants, and we use Climate Earth for that. But I'll log into Climate Earth and create, if we don't have an existing mix, then I'll create a draft version of a mix and get my GWP number, put it in a spreadsheet, and then help develop a realistic carbon budget based on the materials that we have to work with. There's times where our customers don't necessarily want to share the structural general notes or specifications. There's many times where we don't get access to that information. We're asked by our customers a lot of times, hey, I need a 3,000 PSI or 4,000 PSI for a slab on grade, but they don't tell us it's a 0.40, 0.45 water cement ratio, or the exposure category is freeze thaw, F2. This information is important. We have limitations. We need to know production schedules. We need to know pour rates. We need to be sure that we communicate as a ready mix supplier what our plant configurations and capabilities actually are. One silo of just cement or one silo of just ash. Typically we need ternary blend mixes, and we need 3 silos. And we don't have that everywhere. And the question is why? Well, we have air permits that we have to meet or have to adhere to. And a lot of times when we want to expand production capacity, then we're not able to simply do an air permit that's tied to a given production capacity at our facilities.
That's one thing too, that the novel products, what we found too is we've had a lot of discussions with really ready mix manufacturers, and they'll say, Leo, you're bringing me technology from 2030, but my plant is from 1950. And so you do have that grind of not enough storage capacity. And again, rightfully so, that's where the conversation of scalability comes in. If I'm going to dedicate capital to a silo, can you produce it? If I'm going to open up bin space for your aggregate or your filler, do we have that capacity? So those conversations too are ones that don't show up on a slide, but every time we get ready to go somewhere, it's like, okay, how are you going to get this into my material? And so I think as the ready mix and cement, really more ready mix, starts to progress and have confidence in these things, they're going to have to retrofit facilities. And a lot of that is going to be done either technically through AI or something like that, or really in the physical assets of silos and trucks. So a couple of case studies for us. We were fortunate enough to be one of the products that was awarded during Climate Week for use on Governor's Island in New York. So what they're going to do with Governor's Island is revitalize that island and really look at ways to introduce new products. And so we were able to pour out there on right outside of Yankee Pier. So if anybody's from New York, you go to Governor's Island, come off of Yankee Pier, and our materials there. Going into 2026, we will be used with our material in the hardscapes, so using it on pavers and block as well as the ready mix piece. This was really a long time for us to get to this point. It was proving that we could do it, proving that the material would withstand it. This is really in a roadway, which a year ago we would have said, okay, we'll do the sidewalk, but now we have more confidence. The only thing I would change is they exposed finished in the roadway, which we didn't know until the day we were pouring. So we'll just kind of see how it goes with snowplow removal, but we're excited for the durability. And New York has been, again, another one of those legislations where they have laws and standards that specifically call out building materials and reduced carbon. So going forward, we'll be heavily involved in this. But again, this was a lot of collaboration with SOM, who's the architect. They're also a strategic partner, but still they had to have the confidence to say, okay, we're willing to go to the climate exchange and make sure that we can do this going forward. So that was one. The data center market has been a big one for us. that really came to us, and the way we've had it is the data center companies will find a general contractor and then say, hey, we would like to use this material. This was a project that they did. Again, they wanted to see how it would work. They used not only our material, they had other materials that were being tested at that time. We poured this down in Florida. This was an interior slab design that we poured outside just to see how it would take. So they did different cures. They used a laser screed. They did some vapor barrier, some just exposed. And so really that's what we're seeing now in a lot of these test pours, is really trying to cover as many different techniques and things that would impact the ready mix. So we've done pumping, we've done hard trowel finish, we've done exposed, and really we've been open to all of it, because, you know, even if you if you weren't successful, at least you're getting feedback, and that's a big piece. And I think sometimes in darkness, any light is valuable. So even having an audience today that says, okay, these guys have poured somewhere, or one of these products has done it, is good, because it just kind of goes into the community. So those are some that we're working on right now, which has really helped us gain a lot of confidence from the building and construction material industry.
And this is just an example of a carbon budget that we talked about before. I mean, obviously, you know, it's not individual mixes, it's the entire project, cumulative project. So in this example, walls, we exceeded the carbon target, and then beams as well. But ultimately, we end up with reduced carbon content just because of, you can move around that carbon, for example. Typically, you would get it we would increase in columns and shear walls, and then to address the contractor's concerns, we would minimize SCM contents and increase the carbon content of the hard troweled finishes. But yeah, that's it.
There you go.
Thank you.
Thank you. Thank you.